Hello everybody, this is a Lenovo X1 Carbon Generation 3 laptop that I'm just doing a little bit of work on for somebody. But I thought I would use this as an opportunity to see how the input voltage works for the Lenovo. We've already done a Dell, we've done a Toshiba, so I've got a schematic for this one, and I'm going to just follow the path of the 20 volts in this case in through the power jack and just see where it goes from there and compare it to how the circuit works for the other manufacturers' laptops. So why not join me for the tour? So this is the motherboard for our little Lenovo X1 Carbon Generation 3. As you can see, it's not similar to the shape of the other motherboards. This is more rectangular shaped because it has to, when you look at it, this is up at the back of the laptop and the whole front area within the chassis is taken up by a very thin battery. But this is where our power comes in up here. So what I'm going to do next is I'm going to focus on where our power comes in, and then we're going to try and track it across the board. I've zoomed in on where the power adapter connects in. Now most of the Lenovos have it's a rectangular shaped connection. It's not the circular connection that most other laptops use. This one is the same dimensions as a USB type A connection. Dangerously so, one might say. But that's connected in here, and we have 1, 2, 3, 4, 5 pins. Now when I look at our schematic for this, which is right here, I can see our DC connection here. So it's saying ground, power, detect, power, ground, 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 ground. Now I've only 5 visible pins on this, but look, I'm not going to get too worried about it because I know that there's going to be power in, there's going to be grounds, and there's going to be detect, and I know the next component is F2. So we need to just verify that there's 2 of these have the incoming power. It was 20.4 when I measured it on the power adapter, so we should be getting that where it hits the board as well. So what I want to do here now is introduce my digital multimeter, and it's in volts in DC in the 20 volt range. I'm going to place my black probe to ground, and with my red probe I'm going to measure each of these pins in turn. And when I measure these, here are the voltage readings that I got. So on the top pin we have 0 volts, so that's most likely a ground. We have power on this one, 20.4 volts, 0.9 volts on this, which is mostly likely our detect pin, 20.4 on this, and then another ground pin down here. So there's no visual line drawn from our 20 volts to our fuse, but there's no trace showing that it's taken this path. But fortunately, because we have a schematic for this, I can see that our power pin comes in and goes straight on to fuse F2, so we can see it right here. So the next step is to get my multimeter and measure right here. So I measure here and I find that there's 20.4 volts on the input of the fuse. So the first thing then obviously is to verify that the fuse is good, so we simply bring the multimeter to the other side and I measure that there's 20.4 on the other side of the fuse, so our fuse is good also. The question next really is, we've got our 20.4 volts on either side of the fuse, but where does it go next? Because we've no really obvious indication on the board itself as to where it's going. Now if I was to guess, judging from our other motherboards, our Lenovo and our Dell that we looked on the channel previously, there should be probably 1 or 2 MOSFETs and then a current sense resistor. So probably the current sense resistor is, the more unique looking component of these, but I don't see one around this area at all. I do see 2 MOSFETs right here, so there's a possibility that Q9 and Q36 are 2 MOSFETs, but then where is the current sense resistor? Now we do have a schematic for this, of course, so I can easily look back on that and see. So let's take a look. Fuse F2 right here. So the next component following along is Q9. The next component then again is Q36, which is another MOSFET, and then we have R380, which is our current sense resistor, and we can see that we have our voltage measurement taken below and our voltage measurement taken after, which is passed on to our power management chip to work out what the current is. But let's see where Q9 is. So here's our F2 and here's our Q9. So it is one of these two. So from Q9 it goes to Q36, which is the next one right here. So it's coming through here. And then we had R380. So let's see if we can locate that. I don't see it anywhere there really. Well, there's a current sense. That's it. That's it up here, R380. So you can see, similar to the Toshiba motherboard, there's really no indication on the board itself as to where the path is. So it's coming from the fuse to Q9 to Q36, then onto R380, and this is seemingly our main 19 or 20 volt power rail. So let's take the measurements from here. So on the pins of our MOSFET right here, I'm going to take our voltage measurement. So let's get a look at what this is first. So from our schematic, I can see that that first MOSFET is this one right here. So it says the P channel 30 volt MOSFET. So we can see our pin markings here. So for some reason it's showing the drain and gate and source on the underside of it as opposed to showing them on the top side. I don't know why they've done that. But we can mark those out on the MOSFET right here. So if I do that, we've got our 3 source pins right here, gate pin, and 3 drain pins right here. So if I measure on the source right here, I find that there is 20.4 volts. But when I measure on the gate pin, there's only 6 volts. So you might have seen from the other examples that I've done, usually it's been 19 volts on the pins here, and then the gate pin is usually high. However, in this scenario, it is a P channel. As you can see here, it's a P channel MOSFET. So P channel MOSFET is switched on when the voltage on the gate is low. So when we have 6 volts on this gate pin right here, that means that this is switched on. So when I measure on the pins on the other side, these are actually 4 drain pins, but they're in sort of blocks of 2. So we have 2 of the drain pins here and 2 of the drain pins here. So when I measure right here, I find that this MOSFET is switched on and I have 20.42 volts at this point also. So we're good through our first MOSFET, but we're now on to Q36, which is the next MOSFET in the path. So if I look at my schematic, I find out that it's this MOSFET right here. So it's an N channel 30 volt MOSFET. First MOSFET was a P channel, which is turned on when the gate is low. The N channel is turned on when the gate is high. So we can see our pinouts right here, source, 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 gate, and then drain pins on the other side. So looking at this on our image, I'm going to mark in those pinouts. So we've got our source pins right here, our gate pin right here, and our drain pins on the other side. So once again, we should expect to see our 20.4 volts here. When I measure on this, I find that there is 20.4 volts here. And if this gate is high, that switches the MOSFET on, and we will see the 20.4 on this side also. So I measure the gate pin right here, and I measure 24.5 volts on it. Now that 24.5 volts is a high signal, so that switches on the MOSFET, and when I measure right here, I find that there's 20.4 volts on the other side of our N channel MOSFET as well. So once again, back to our little data sheet here, our schematic. So we know that we're good, just looking at this on the schematic. So we had 20.4 volts on the source, our gate pin was 24.5 volts, which turns it on, and that allows our 20.4 volts to come through to this point here, which is where we are right here. So as we know from our schematic shows us that the next component in series is R380 right here. So we need to find that, and that is actually all the way over here. So can you spot it? So that is actually the next one in series. So once again, I just measure here and I find that there is 20.4 volts at this point, and I measure the other side of the current sense resistor and I find that there's 20.4 volts right here as well. So we have 20.4 volts after our current sense resistor. If I take a look at that on the schematic, you can see right here that after the current sense resistor, this is then referred to as V int 20. and V-in20 is our main 20 volt power rail on our Lenovo. It's 20 volts on the Lenovos for some reason. You might have remembered that our Dell was 19 volts and our Toshiba was 19 volts. Doesn't really make any difference, but they use 20 volts for theirs. So as you can see, and I'm probably doing this to death at this stage, but I think it's quite interesting to see that they are actually quite similar on all of the different brands of laptops. You have an input connector, whether it be like the rectangular connection on the Lenovo or the circular one for the Dell or whatever. The purpose of it is basically just to bring your power onto the motherboard. You can then measure the voltages as it enters the motherboard. You then have like a fuse, or I think there was an inductor in the Toshiba. You then have 2 MOSFETs usually, and then a current sense resistor. You'll know it's a current sense resistor because if you physically see it, it's going to be really big, and it will also have 2 lines away from it that are used to measure the current going into the board. So you can see how it's quite similar. I'm probably doing this to death with each of the ones, but I think it's actually quite interesting to see, to follow the path of the main power rail for our Dell, for our Toshiba. This is our Lenovo, and I have a HP, so I'll probably do that as well. I have to get this back to somebody pretty quickly, so I don't have time to put together the measurements of the inductors, but I'll do that in another video. And hopefully we'll have something a little more interesting next week. Unfortunately, I'm not getting in anything interesting. I'm just getting in like hinge fixes and screen replacements and stuff like that. So there's nothing worth making a video on. But if I have a week like the last few weeks where there is nothing interesting, I'll just go through one of these working laptops and see if we can build up a better knowledge of the input circuit. And if it gets really bad, I might actually just blow up a laptop and then try and fix it. We'll see what happens with that. But that's it for this week. Please like and subscribe, and I'll be back with something else next week.